Hey, welcome back to Rapid Review Series for Honors Physics. Today we're going to talk about graphical estimation. This is a continuation of the presentation we saw recently called Area Under the Curve, and we're going to look at a way to estimate areas when you don't really know the equation of the line. I will remind you that what we learned last time is you can take area under the curve, and that represents displacement. We made the point that displacement and distance are looked at differently. If you have a velocity time graph, you can get displacement, and then from that you can take the magnitude of displacement and get distance. So here in this graph, we know that the area of a triangle, like under A, is the displacement. It's positive, it's above the line; negative, it's below the line. And if you want the distance, you just take the magnitude of those areas. Now, if you ever get something that looks like this, like a speed time graph, all you can do is get distance, right? Because there's no vector information in a speed time graph. So if you have a graph that looks like this, you can calculate the areas, you'll get distance, but you will not get displacement. Just remember that. Now, for the really interesting thing, how to estimate area in a graph. If you look at this graph that's provided, it's some arbitrary velocity versus time graph. And the question is, what was the displacement during this trip? Let's focus on just the time between 0 and 2. We're going to focus on that time duration, and we're going to try to estimate the area under this curve. Now, it's a weird shape. We're not even given the equation of it, but you can do it by understanding that each square in the graph has a meaning, right? Each square has a vertical size of 1 unit. I'm going to zoom in again. This is velocity in meters per second. Remember that. So this is 1 meter per second up and 0.5 seconds over. So 1 times 0.5. 1 square in this graph represents 0.5 meters. Remember that. So this is, I'm just going to do that, 0.5 meters. I'm going to just remember that because it's going to be useful later. Let's get rid of this and let's get to work. So if I wanted to estimate this area, I know how to do triangles and squares and rectangles. Here I'm going to approximate this as, let's say, I'll do a rectangle and a triangle. And you can see that the rectangle is a pretty good representation of the area under the curve, but I'm probably clearly overcounting the area under in the triangle, because you can see that that's not very accurate. So we can improve that if we imagine this area as something else. So you can visualize this any way you like. I'm going to get rid of the old lines, and I'm going to visualize it a little differently. Maybe I could think of this trapezoid here from 0 to 1. That looks pretty close. I have a little mess up at the top, but that's not too bad. That's pretty close. And I can think of maybe this trapezoid here. And I say trapezoid, you can think of a trapezoid as a trapezoid geometrically, or you can think about it as a square plus a triangle. But you can see already I've greatly improved my estimate. All I have to do is calculate the area of those trapezoids or rectangles and triangles, and I'm in good shape. Now, there's yet another way you can look at it. You can just, because you know the number or the value of a square, you can just count the squares. Let's try that method. So I'm going to erase my old work again, and I'm going to count squares. Let's see here. I've got 1, 2, 3, 4. I'm noticing where the clear squares are, and then I got some weird fractions. Let me say that this one, which is really only a half a square, adds up with this one, which I won't count, and I'm going to be pretty close with my estimate. Likewise, I'm going to count this square, but there's all this wrong area there. That roughly compensates with the area up there. So I should be pretty close. If I count all these squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, if I multiply 13 squares times the value of a square, which is, in this case, 0.5 meters, I should get a pretty good estimate, right? So that's 6.5, just did the math in my head, 6.5 meters of displacement. If you did your estimate and you got 7 or 6 or 6.2 or whatever, that's okay, because remember, we're only estimating. I have found in talking to students, everybody visualizes this differently and does it a little differently, but you end up with the correct answer or pretty close, which is the point of an estimate, every time you do it. So that's all I have to say about estimating areas graphically. We're going to come back to this in future lessons. It's a useful skill. That's all we got for today.